There's a question that's been quietly unresolved for over a year now, and it's one of the strangest, most consequential mysteries to come out of the entire war with Iran. On the night of June 21st into June 22nd, 2025, 7 American B-2 Spirit stealth bombers flew a mission 15 years in the making, dropping 14 of the most powerful conventional bombs on Earth onto Iran's most heavily fortified nuclear facility. The strike was called Operation Midnight Hammer, and within hours, President Trump was standing in front of cameras declaring the site obliterated. But more than a year later, nuclear inspectors still cannot tell you with certainty whether Iran's nuclear program was actually destroyed, whether it was merely delayed, or whether several hundred pounds of nearly weapons-grade uranium simply vanished out the back door before the bombs ever hit. So today we're going deep into exactly what happened that night at Fordow, how a mountain in the middle of Iran became the single hardest target the United States military has ever had to solve, what the bombs actually did once they hit, and why, even now, nobody, not the Pentagon, not the CIA, not the United Nations' own nuclear watchdog, can agree on the answer to the most important question of all. Did it actually work? Let's start with why Fordow exists in the first place, because understanding the target explains almost everything about why this strike required such an extraordinary weapon. Fordow isn't a normal nuclear facility sitting out in the open like Natanz. It's buried deep inside a mountain near the city of Qom, specifically because Iran built it to survive exactly the kind of attack that eventually came for it. Its main enrichment hall sits somewhere between 80 and 90 meters underground, roughly 260 to nearly 300 feet beneath solid rock and reinforced concrete. Analysts had said for years that the United States was the only military on the planet with a weapon even theoretically capable of reaching that deep, and that weapon was the GBU-57 Massive Ordnance Penetrator, a 30,000-pound bomb, roughly the weight of a city bus, compressed into a steel cylinder about 20 feet long and 2.5 feet thick. It is, quite literally, the only weapon of its kind in the world. And here's the detail that matters most for understanding the entire strategic dilemma behind this mission. The weapon was designed from the very beginning to solve exactly one problem, hitting Fordow without crossing the line into using an actual nuclear weapon to do it. Reports on the strike's development describe the entire Fordow mission as 15 years in the making, meaning American planners had been building, testing, and refining this specific bomb against this specific mountain since long before this war ever started. It's worth pausing on just how long the United States had been preparing for this single mission, because it changes how you should read everything that happened afterward. The GBU-57 program traces back to the mid-2000s, developed specifically in response to growing American concern about exactly this kind of deeply buried, hardened facility becoming the preferred way for adversarial states to shield their most sensitive weapons programs from airpower. Fordow itself wasn't even publicly disclosed until 2009, when Western intelligence agencies revealed its existence, and from that point forward, American defense planners treated it as the primary design driver behind this entire weapon system. Testing and refining the GBU-57 against increasingly realistic mock-ups of exactly the kind of layered rock and reinforced concrete Iran was believed to be using. That means by the time these bombs actually fell in June of 2025, the weapon dropping on Fordow wasn't a rushed, improvised solution to a sudden crisis. It was the end result of roughly a decade and a half of purpose-built engineering aimed at solving one specific problem, hitting one specific mountain. And it still took 12 of these bombs split across 2 separate impact channels, firing in rapid succession down the same holes, to have a real chance at reaching the depths involved. It also helps to place the Fordow strike within the broader window of fighting that both American and Israeli forces refer to as the 12-Day War, because the bunker buster mission didn't happen in isolation. Israel had opened its own campaign against Iran's nuclear infrastructure on June 13th. Striking Natanz first and causing enough disruption to the site's electrical systems that, according to the IAEA's own assessment, the resulting power loss likely sent Natanz's above-ground centrifuges spinning wildly out of control on their own, destroying much of that equipment before a single American bomb was ever involved. Iran's foreign ministry sent its letter about protective measures for its nuclear material that same day, June 13th, which tells you Tehran clearly understood from the very first hours of Israeli strikes that a far larger and more direct threat to its enrichment infrastructure, and specifically to Fordow, was likely coming. The American strike on Fordow itself came roughly a week and a half later on the night of June 21st into June 22nd, meaning Iran had a genuine window measured in days, not hours, to consider what protective measures it wanted to take with its most sensitive material before the GBU-57s ever left the bomb bay of a single B-2. Now here's where the physics of this get genuinely fascinating, because a bomb like this doesn't work the way most people picture a bomb working. This isn't about a giant fireball punching straight through solid rock like something out of an action movie. The GBU-57 is officially rated to penetrate roughly 18 meters, about 60 feet, of reinforced concrete under specific pressure conditions. Against the kind of rock and reinforced material Iran actually used at Fordow, independent analysts had assessed before the strike that the effective penetration depth would likely fall well short of the facility's true depth on a single hit. So how do you solve that problem? You don't rely on one bomb punching all the way through in one shot. According to details the Pentagon has shared since, several of these bombs were dropped in immediate succession into the same entry points, essentially using the first bomb to punch through the initial layers and clear a path, with subsequent bombs following down through that same channel to reach progressively deeper. Reporting following the strike confirmed that 12 of the 14 bombs used that night were aimed at Fordow specifically. 6 bombs sent down each of 2 separate impact points, effectively creating 2 parallel assault channels straight down into the mountain, while the remaining 2 bombs were used against Natanz, Iran's larger and more exposed enrichment site. Once a penetrator reaches its target depth, it doesn't detonate on impact like a conventional bomb. It's built with a delayed fuse specifically, so the explosion happens after the casing has already buried itself as deep as physically possible, turning the weapon into something closer to an engineered underground earthquake than a traditional blast. Defense officials who briefed reporters afterward described the majority of the actual damage as coming not from the explosion itself, but from the blast layer and the shockwave impulse extending outward from that detonation point, a distinction that matters enormously once you understand what enrichment facilities are actually vulnerable to. And that's the detail that makes this weapon so uniquely suited to this target. Uranium enrichment relies on centrifuges, thousands of them, spinning at extraordinarily high speeds, with tolerances so precise that even minor vibrations can knock them completely out of alignment or destroy them outright. You don't necessarily need to physically crush every centrifuge in a direct hit to render an enrichment hull useless. You just need to generate enough seismic level shaking through the surrounding rock to send those centrifuges spinning out of control. In fact, that's exactly what happened at Natanz, a separate facility that was hit earlier by Israeli strikes that disrupted its electrical system, rather than physically penetrating its underground halls. The head of the International Atomic Energy Agency said publicly that he believed the resulting loss of power at Natanz could have sent the centrifuges there spinning out of control on their own, likely destroying all of them without a single bomb ever directly touching the underground chamber. That's worth sitting with for a second, because it tells you something important about how fragile this kind of technology actually is, despite being buried under mountains of protection. The delicate, precise machinery required to enrich uranium is, in a strange way, one of the most physically vulnerable pieces of equipment in the entire nuclear weapons chain, precisely because it has to be so exact to function at all. So what actually happened when those bombs went off at Fordow? Satellite imagery captured by Maxar Technologies and analyzed independently by outlets including CNN showed at least 6 large craters at the site, clustered in 2 separate nearby locations, exactly matching the 2 6-bomb impact channels described by defense officials. Those craters were the visible fingerprint left behind by a weapon designed to do almost all of its real damage, somewhere the cameras couldn't see. President Trump, in the immediate aftermath, was unambiguous, saying the site was obliterated and insisting that everything nuclear inside had been buried under granite, concrete, and steel before Iran ever had a chance to move it. Defense Secretary Pete Hegseth used equally forceful language, claiming the operation had obliterated Iran's nuclear ambitions outright. And to be fair to that framing, the officials at the Defense Threat Reduction Agency, the Pentagon office that spent over a decade helping design this weapon specifically for this mission, said afterward that they were confident, even while still waiting on more detailed assessments, stating plainly that they were able to strike the facilities as planned and strike exactly where they intended to strike. That's a meaningfully different claim than saying the facility was completely destroyed. It's a claim about targeting accuracy, not about the ultimate fate of everything buried underneath. And that distinction is exactly where this story stops being simple. Because almost immediately after the strike, a rift opened up right in the middle of America's own intelligence community about how much damage had actually been done. A preliminary assessment from the Defense Intelligence Agency concluded that an unknown amount of Iran's highly enriched uranium had been moved out of Fordow before the bombs ever landed, potentially relocated to a third site that Iran had reportedly told the IAEA about in advance. Defense Secretary Hegseth pushed back hard against that leak, insisting the assessment was merely preliminary and inconclusive. But then CIA Director John Ratcliffe came out with a competing assessment of his own, saying the CIA's analysis directly contradicted the DIA's findings and that Iran's nuclear program had been, in his words, severely damaged. So within days of the strike, you had 2 of America's own intelligence agencies publicly disagreeing about whether the central goal of the mission had actually been accomplished. That's an extraordinary thing to witness play out in public, and it set the tone for everything that's followed since. Here's where the mystery deepens even further. and it centers on a substance that, as of right now, still hasn't been fully accounted for. Before the strikes, Iran had accumulated roughly 400 kilograms of uranium enriched to 60% purity, sitting just below the 90% threshold generally considered necessary for a functional weapon. On its own, that amount is theoretically enough material to produce somewhere in the range of 9 nuclear devices if enrichment were pushed the rest of the way. On June 13th, just days before the American strikes, and right as Israel began its own separate bombing campaign against Iranian nuclear sites, Iran's foreign ministry sent a letter to the IAEA stating that Tehran would, in its own words, adopt special measures to protect its nuclear equipment and materials. No further details were given about what those measures actually involved. The IAEA's Director General responded at the time, making clear that any movement of nuclear material out of a safeguarded facility was required to be formally declared under international rules, and that Iran was expected to comply with that requirement, even while exercising its right to protective measures. Whether Iran actually followed that rule is precisely the question nobody has been able to definitively answer since. In the days immediately following the strike, the IAEA's Director General said publicly that his agency did not know where the material was, describing nearly 900 pounds of potentially enriched uranium as essentially unaccounted for. He was careful, notably, not to speculate beyond what his agency could actually confirm, saying explicitly that the IAEA does not deal in speculation, and simply did not have direct information on the material's whereabouts. Over the following months, the picture shifted several times, and it's worth walking through that evolution honestly, rather than picking whichever version fits a more dramatic narrative. By late August of 2025, satellite imagery reviewed by the agency reportedly showed no clear evidence that nuclear material had been physically moved away from the declared sites, suggesting the bulk of the stockpile may have simply stayed in place, buried under whatever remained of the facilities. But independent analysis from nuclear watchdog groups studying the same imagery drew a more nuanced conclusion, noting that Iran had, in fact, already relocated a significant portion of both its 20% and 60% enriched stockpiles to Isfahan well before the June strikes even happened, storing that material specifically inside Isfahan's own underground tunnel complex, out of what appears to have been a long-standing contingency plan rather than a last-minute scramble. That detail matters enormously because it suggests Iran wasn't simply reacting to an imminent attack. It may have been quietly hedging its most sensitive material across multiple locations for weeks or months in advance. Exactly the kind of behavior a state actively trying to preserve its weapons-relevant material against exactly this scenario would engage in. Then, in late October of 2025, the story shifted again. The IAEA's Director General told reporters that inspectors had observed movement around the very sites where enriched uranium stockpiles were believed to be stored, language notably different from the earlier assessment that nothing had moved. As of a comprehensive update issued in mid-November of that year, the agency's official position remained that the enriched stockpiles had not been moved away from their original sites entirely, but the agency was careful to add that this did not necessarily rule out material being shifted around within those same site complexes. So, even 5 months after the strike, with the world's foremost nuclear inspection body actively working the problem, the honest answer to the simplest possible question, where is Iran's uranium, was still somewhere between "we're not sure" and "it depends what you mean by moved." That is an almost unprecedented level of ongoing uncertainty for a stockpile of material that size, sitting at the center of one of the most consequential military strikes in a generation. It's worth putting the missing 400 kilograms of 60% enriched material into the context of everything else Iran had stockpiled at the time, because the 60% material was really just the tip of a much larger pile. According to the IAEA's own comprehensive assessment from mid-May of 2025, roughly a month before the strikes, Iran had accumulated close to 275 kilograms enriched up to 20%, well over 5,000 kilograms enriched up to 5%, and more than 2,000 additional kilograms enriched up to 2%. On top of that, 408 kilograms of material, enriched all the way up to 60% purity. Put all of that together, and independent trackers have estimated Iran's total enriched uranium stockpile across every purity level at somewhere around 8,500 kilograms as of that same period. The 60% material gets almost all of the public attention because it sits so close to weapons-grade purity that finishing the enrichment process from there is a relatively short technical step compared to starting from scratch with natural uranium. But the sheer scale of everything else sitting in that stockpile is a reminder that even a fully successful strike against Fordow specifically was never going to erase Iran's broader nuclear infrastructure and material base in a single night. It might take out the single most sensitive and most difficult to replace portion of that stockpile, But a program spread across multiple sites, with materials stored at multiple purity levels, was always going to be a harder thing to fully eliminate than one dramatic strike on one mountain, no matter how large the bombs involved were. If you want a simple way to picture the actual challenge American planners were up against here, think of it less like trying to blow up a single building, and more like trying to permanently shut off a factory by destroying only its most expensive, most specialized machine, while the blueprints, the trained workforce, and the rest of the supply chain all survive completely intact somewhere else. You can absolutely set that factory back in a meaningful way. You can force it to spend months or years rebuilding equipment it can no longer easily replace. But calling that factory permanently closed, when the people who know exactly how to rebuild it are all still alive, still employed, and still holding on to raw materials stashed in a separate warehouse across town, is a much bigger claim than the physical damage alone can actually support. Let's also talk about what the satellite imagery has actually shown happening at the site itself in the time since, because Iran's own behavior at Fordow tells its own story. Within days of the strike, new commercial satellite images showed heavy earth-moving equipment arriving at the site, along with excavators and cranes working directly around the impact craters left by the bunker busters. Construction trucks were spotted along roads leading straight to the strike points. A weapons expert who has closely tracked Iran's nuclear program for years assessed that this activity most likely represented Iran filling in the craters, conducting its own internal engineering damage assessments and gathering radiological samples to understand exactly what condition the underground facility was actually in. New access roads even appeared connecting the site's tunnel entrances to some of the impact craters. And separately, Israel's Air Force conducted its own follow-up strikes specifically aimed at disrupting continued access to the site, suggesting Israeli intelligence believed Iran was actively working to reassess or even begin repairing the facility, rather than simply abandoning it as a total loss. By the time a more comprehensive assessment was published roughly 5 months after what's now generally referred to as the 12-Day War, independent nuclear analysts studying the site in detail described the tunnel portal entrances as still backfilled with soil, essentially sealed shut, and identified specific ventilation shafts that had been successfully targeted and destroyed during the strikes. The IAEA's own verification and monitoring report from that period stated plainly that Fordow's fuel enrichment plant was expected to have suffered very significant damage as a direct result of the military strikes carried out between June 13th and June 24th. That's about as close to an official, credible answer as exists on the record right now. Very significant damage, backed by physical evidence of destroyed infrastructure and sealed tunnel access, but stopping meaningfully short of a declaration that the facility, or the material inside it, was completely and permanently eliminated. So where does that leave the Pentagon's own internal assessment, the one meant to actually settle this question using far more sensitive tools than commercial satellite photography? According to reporting on internal Pentagon deliberations, officials involved in evaluating the strike's success described a comprehensive battle damage assessment as still being compiled well after the operation, run through the same Defense Threat Reduction Agency office that spent over a decade designing this exact weapon for this exact mission. That agency has said it intends to use whatever conclusions come out of that assessment specifically to inform improvements to the next generation of deep penetrating weapons, including a follow-on system currently referred to as the Next Generation Penetrator, envisioned with an attached rocket booster for standoff strike capability and dramatically improved precision, along with a separate, smaller bunker-busting weapon, small enough to fit inside the internal weapons bay of stealth fighters like the F-35. The fact that the United States is already actively developing a more advanced successor to the very weapon it just used for the first time in combat tells you something important all on its own. If the GBU-57 had unambiguously, completely solved the Fordow problem on its first operational use, the pressure to immediately fund and design something even more capable would be considerably lower than it currently appears to be. And that brings us to what might be the single most revealing detail in this entire story, one that came out well before the bombs ever dropped. According to people familiar with the deliberations inside the White House in the lead-up to the strike, President Trump himself expressed hesitation about authorizing the operation, specifically because he wanted assurance that the bunker buster bomb would be guaranteed to actually destroy Fordow. Defense officials told him that dropping the GBU-57s would effectively eliminate the site, but by multiple accounts, he did not appear fully convinced, and he reportedly held off on authorizing the strike for a period of time, partly in hopes that the mere threat of American involvement might push Iran toward a negotiated settlement instead. Even more strikingly, reporting indicated that the effectiveness of the GBU-57 against a target this deep had been a subject of genuine ongoing contention inside the Pentagon well before this war even began, with some defense officials privately briefed that perhaps only a tactical nuclear weapon would truly be capable of destroying Fordow, given exactly how deep the facility sits beneath the mountain. To be absolutely clear, The reporting is equally clear that a tactical nuclear option was never actually presented to the President by his Defense Secretary or the Chairman of the Joint Chiefs, and it was not what ultimately got used. But the fact that serious, credentialed defense officials were privately debating whether America's most powerful conventional weapon might simply not be enough, and that the sitting president himself wanted a guarantee, before pulling the trigger, that even his own advisors apparently couldn't fully provide, tells you everything about how close this entire strike sat to the absolute edge of what conventional military technology can actually achieve. There's a broader argument some defense analysts have made since the strike that deserves serious consideration here, because it reframes the entire obliterated or not debate in a more useful way. The prevailing, simple narrative that settled over much of the public conversation after Operation Midnight Hammer was that the strike proved conventional precision weapons can now achieve what once required an actual nuclear weapon, effectively making certain categories of tactical nuclear weapons strategically unnecessary. But a closer read of the Pentagon's own language complicates that tidy conclusion. The official damage assessment concluded that Iran's nuclear program had been set back by approximately 2 years, a characterization that matters as much for what it doesn't say as for what it does. It doesn't claim destruction. It doesn't claim elimination. A 2-year setback is a serious, meaningful blow to any weapons program, but it is fundamentally a description of delay, not annihilation. And tellingly, the same Pentagon that just used its most powerful conventional bunker buster for the first time in actual combat has, in its own budget documentation, continued actively funding research into the very small handful of deep strike categories that conventional weapons still can't reliably reach. That's not the behavior of an institution that believes it has fully solved this problem. It's the behavior of an institution that narrowed a gap it once thought might require a nuclear weapon to close without actually closing that gap completely. Let's also be honest about the timeline of warnings that came directly from the world's own nuclear watchdog in the weeks after the strike, because they cut directly against the simplest version of the mission accomplished narrative. Even as Tehran itself was forced to publicly admit that Fordow had been badly damaged, the IAEA separately warned that Iran could plausibly resume enrichment activities within a matter of months, not years, depending on how much of its centrifuge manufacturing capability and technical expertise survived the strikes intact. Manufacturing brand new centrifuges from scratch is a slow, technically demanding process, but replacing damaged equipment using existing designs, expertise, and any surviving components is a fundamentally faster undertaking, and that's precisely the scenario the IAEA appeared to be flagging as a live possibility. Put simply, destroying a facility's current output is one thing. Destroying a nation's accumulated technical knowledge, engineering talent, and existing stockpile of raw material is an entirely different and far harder problem, and it's one that no conventional bomb, no matter how large, can fully solve on its own. There's also a quieter irony sitting inside this entire debate that's worth pointing out before we wrap up. The very fact that senior American defense officials privately wondered whether only a tactical nuclear weapon could truly finish the job at Fordow tells you that this strike, however dramatic and however successful in its own right, effectively became the real-world stress test for the entire premise that conventional precision weapons had made certain nuclear options obsolete. Fordow was, in a sense, the single hardest possible proving ground for that premise, because it was purpose-built by Iran specifically to defeat exactly this kind of conventional attack. If the GBU-57 had cleanly and completely solved that problem on its first combat use, you would expect the internal Pentagon debate about needing something nuclear adjacent to have been settled decisively, rather than continuing to surface in reporting for months afterward. Instead, what actually happened looks more like a partial validation. Conventional weapons proved capable of reaching further and doing more damage than many analysts had assumed possible, while still leaving enough uncertainty about the ultimate outcome that the Pentagon kept both its most sensitive internal debates and its funding for next-generation successors very much alive. So let's bring all of this together into the honest, complete picture, because that's really the answer to the question sitting at the center of this whole story. Can a mountain stop a 30,000-pound bunker buster bomb? The evidence says, mostly, no. The GBU-57 did exactly what 15 years of design work built it to do. It punched down through the layers of rock and reinforced concrete protecting Fordow, using repeated strikes down the same channels to reach depths a single bomb almost certainly couldn't achieve alone, and it very likely generated enough shockwave energy to destroy the delicate centrifuge equipment inside, even without physically crushing every piece of it directly. Satellite imagery, official IAEA assessments, and even Iran's own admissions all point toward genuinely severe, significant physical damage to the facility itself. But the deeper question, whether the strike actually eliminated Iran's underlying nuclear capability rather than simply setting it back, remains genuinely unresolved more than a year later. Several hundred kilograms of material that sits uncomfortably close to weapons-grade purity still cannot be definitively accounted for by the one international body whose entire job is tracking exactly that. Iran's own technical knowledge and engineering base almost certainly survive largely intact, since you cannot bomb expertise out of the people who possess it. And the Pentagon's own internal debate, both before and after the strike, suggests that even the people who built this weapon for this specific mission were never fully certain it would completely finish the job on its own. That's the uncomfortable, complicated truth sitting underneath all the dramatic headlines from that night. A mountain can absolutely be cracked open. A bomb that big, dropped with that much precision, using repeated strikes down the same access channels, can reach depths that once seemed physically impossible to touch with anything short of a nuclear weapon. But cracking open a mountain and permanently eliminating everything a determined, well-resourced state has spent decades building underneath it are not automatically the same achievement. Fordow got hit exactly where American planners intended, exactly the way 15 years of engineering said it should be hit. Whether that was enough to actually end the program buried inside it is a question that, more than a year on, still doesn't have a fully settled answer, and probably won't until either Iran's own actions or a far more invasive round of international inspection finally forces one. So here's what I want to hear from you. Do you think Fordow's nuclear capability was genuinely crippled by that strike? Or do you think Iran managed to preserve enough material and enough expertise to eventually rebuild what was lost? It's a genuinely difficult call, and honestly, based on everything the IAEA, the Pentagon, and Iran's own state media have each said at different points over the past year, it's a call that reasonable, well-informed people keep landing on differently, which is exactly why it's worth talking through together. Drop your take in the comments, because this is exactly the kind of story where reasonable people looking at the same satellite images and the same official statements can land in very different places. If this breakdown helped to make sense of a story that's honestly been confusing and contradictory for over a year, go ahead and hit that like button, share it with someone who's still wondering what actually happened that night, and subscribe so you catch it the moment any new inspection report or satellite update finally moves this story off the fence it's been sitting on since June of last year.